This is our Intro to Equations and Inequalities practice set. As always, pause the video to work these problems, then come back to check your work. Okay, so let's start going through these. These are basically verifying whether or not a given number is a solution to an equation or inequality. And it might seem like this is not a big deal, but it really solidifies for us what a solution is, and that definition is universal. And so the more you can get that definition locked in your head early in your algebra journey, I promise it will be a huge, huge asset to you later on as you move to more and more complicated topics. So for number one, we are given the equation 3x plus 1 equals 2x minus 3. And we're given the x equals 4 as a possible solution. So we have not done any algebra work to get an x equals 4. Just somebody hands it to us and says, hey, is this a solution to it? So we know that a solution is the value of the variable that will make the equation true. So what we do is we plug the 4 in, and we plug it in everywhere we see an x. And you'll notice some of our older skills coming into play here. So we know that substitution comes into play, what it means to evaluate, plug in the number and get the value. Order of operations comes into play. So you really start to see the algebra skills building at this point. 3 times 4 is 12. And 2 times 4 is 8. And notice that I am working top to bottom here. So I'm not stringing my work out from left to right across the screen. If you were to ask me as my student, where did you get this 8 from? I would point you right above the 8 to where it says 2 times 4. Also notice that our equal sign is going to track all the way through the problem, and that anything we're not dealing with simply gets copied down from one line to the next as is. 12 plus 1 is 13. 8 minus 3 is 5, and that is what is known as a false statement. 13 does not equal 5. So our answer to the question is no. X is equal to 4 is not a solution. And where this might come in handy for you is on a multiple choice test where you were given the equation and you're asked to choose an answer. You can actually go through and check each of the answers to see which one of those answers will make the equation true. And you can use that strategy even if you don't know how to solve a particular equation. So the second one here is what's known as a quadratic equation, and this comes much further on in your math journey. It is Algebra 1, but it's much, much further on in Algebra 1 than where we are right now. But you can answer the question. So we'll go ahead and we'll plug in the 3. So we have 3 squared, and again, we plug in the 3 everywhere we see an n. And then once again, we need to use our order of operations and our ability to evaluate an expression. 3 squared means 3 times 3, which is 9. 2 times 3 is 6. And then we do adding and subtracting from left to right. So 9 plus 6 is 15. Now notice again the way that I'm laying the work out on the page here, that even though I haven't done anything with the minus 15, the minus 15 comes through all the way. The equal sign comes down all the way. The 0 comes down all the way. And finally, I get 15 minus 15, which is 0. And 0 equals 0 is what is known as a true statement. And so we would answer yes to this. N equals 3 is a solution to that equation because it does make that equation true when plugged in. The next two are inequalities. So, but the same principle holds, which is why it's so important to know what we mean when we say a solution. So we have 4n minus 7 is greater than or equal to 5. We're going to go ahead and plug in that 4 for the n and use our order of operations. So 4 times 4 is 16. and 16 minus 7 is 9. And so we land at the statement 9 is greater than or equal to 5. Well, this is true for the greater than part. So 9 is indeed greater than 5. So this is a true statement, and we would say yes, n equals 4 is a solution to that inequality. For number 4, we have y squared is greater than 0. And later on in your algebra journey, this will be known as a positive interval where something is greater than 0. So we'll go ahead and plug in y is equal to 2. And we have 2 squared, and we get 2 squared is 4. 4 is greater than 0. And that is, oh, I should write the word true there. And so our answer is yes. Okay, same principle at work, just with an inequality instead of an equal sign. Now, these are a little bit more open-ended questions. So I love these kinds of questions because they get you to think a little bit harder. You're not just replicating some steps. Those kind of problems are important to solidify our definitions. But question 5 says, give 3 numbers that are solutions to 2x is less than 20. So there's a lot of different ways you might approach this. And if you have some background in how to solve equations, maybe from a previous math class, you might go ahead and plug in some numbers there. But let's go ahead and do like some trial and error. So let's say x is equal to 1. Plug in x is equal to 1. And so we'll have 2 times 1 is that less than 20. 2 times 1 is 2. 2 is less than 20, which is true. And so we would say yes on x is equal to 1. Then you might say, well, let's do x is equal to 10. Let's see if that works. 10 is a nice, easy number. And so we'll do 2 times 10 is less than 20. That is 20. And we get 20 is less than 20, which is not true. Something can't be less than itself. So that we say is no, it's x equals 10 is not a solution. And so you might try, well, x equals 1 worked and x equals 10 did not work. So let's go with something closer to x equals 1. Let's try x is equal to 2. And we get 2 times 2 is 4, and 4 is less than 20, so that one works. And you might play around with this, and there's a lot of value in playing around with the problem, just plugging in different things to see what works. And I strongly encourage you to do that, because what you will find is that as you increase your values of x, you will get closer and closer to that 20 until you get to x is equal to 10, when it's equal to 20, and it becomes a false statement, and then anything beyond the 10 won't work. And what that will do is it will start to generate in your head a picture of what the solutions might be. So basically, you could pick anything less than 10. Okay, so you could pick 1, 2, 3, 4, 5, 6, 7, 8, 9, but you could also pick something like 9.5 or 3/4. Now, probably you didn't, because I mean, we just tend not to go to those numbers if we have options for nicer numbers, but technically you could. So looking at your own work and your own answer for this problem, if you have any 3 numbers that are less than 10, then you correctly answer this question. There's infinite number of things that you could have picked. The next one is another like ponder this. So how many solutions do you think, this is problem 6, do you think this equation has? And so there's a lot of ways you can do this, and depending on how much math background you have coming into doing this problem or watching this video, you might have some strategies that you could use to arrive at different places. But just start picking a number, like we'll pick x is equal to 2, and you might plug a 2 in. Oh, let's not do that because I'm trying to avoid certain things right now. Let's do x is equal to 10. We'll do x is equal to 10. And we have 10 minus 4, and then 2 times 10 minus 8. So using our order of operations, 10 minus 4 is 6. Over here, 2 times 10 is 20. And 2 times 6 is 12, and 20 minus 8 is also 12, and so 10 works. And then you might play around with this again, and I don't know what we want to pick this time. Let's pick x is equal to, I don't know, let's do x is equal to 6. So we'll do 6 minus 4 equals 2 times 6 minus 8. 6 minus 4 is 2. 2 times 6 is 12. 2 times 2 is 4. And 12 minus 8 is 4. And so that also works. And as you keep playing with this, what you are going to find is that every single number that you plug in actually works. And I was trying to avoid negative numbers because negative numbers, we haven't covered that in a lesson yet. So I'm trying to make sure that the lessons are going in order, at least as far as I can make them go in order. But pretty much like everything is going to work. So you could try plugging in like, I don't know, 5.5, and you'll get stuff that works. And so the answer to this is actually, in terms of how many, there are infinite solutions. And you might also hear this as all real numbers. And we haven't really talked about the real number line, but pretty much that means any number that you can think of at this point will actually work. Now, once we cover some more strategies for solving equations, we'll actually be able to develop an algebraic method to show that all of the numbers, real numbers, are going to work in this. But until we get there, you're kind of left with just explore. And again, there's really a lot of value in playing with this. All right, let's take a look at this last one. Before my video gets too long, write an equation to model the scenario below. You have $100 to spend on phone calls while you travel abroad. You purchase an international phone card for $10, and it will cost you an additional $2 per minute when you call home. For how many minutes can you talk? And so you've got your like $100 here, and $100 is equal to the $10 that you paid for the card plus $2 times however many minutes you talk. So you might have set it up like that. You might also have set it up this way. So $10 for the phone card plus $2 times however many minutes you talk. That has to be equal to the 100. That is called the symmetric property of equality, where you can just switch the sides. Okay, really depends on how you read the problem. You might have done it this way. You might have said to 2m plus 10 is equal to 100. That is going to match the form of a lot of things that we do in algebra to have it written that way. But all of those are correct. And you might even have come up with something much more different. So you might have said something like, I don't know, 5 plus m is equal to 50. Okay, so you might have done that. Now that would be a little bit weird for you to have gone in that direction with it, but it wouldn't be wrong. So hopefully this helps. As always, please like and subscribe if you found this video and problem set helpful. Leave a comment letting me know if there are anything else, any other questions you have, or anything you'd like to see a video on.